in have studied the three different properties, the three different conductors, that are semiconductor and insulator. Okay, so basically in our solid state, the solids can easily conduct the electricity, and the reason behind this is the movement of electrons. Whenever electrons can move very easily, the conduction is also smooth. Okay, but there are some solids which cannot conduct electricity very well, and the reason behind them is that there is a band length which the electrons cannot jump. They cannot jump from the lower position to higher position easily, and if the movement of electron is not possible, that means the conduction is also not even possible. Okay, and that we have studied in the case of semiconductors and insulators. Okay, so basically what we have studied that in our particular class, that electrical properties of solids can also be modified, and we have modified them in the case of like N-type semiconductor and P-type semiconductor. We have added some foreign impurity into them, and we have increased the conductivity. Okay, so this was the whole topic we have covered in our previous class. Now let's start with our today's topic, that is known as magnetic properties of solids. How the magnetic property of solids can be described. Let's start. So basically class, I have already told you that all the properties of solid are only conducted, or we can say only related, due to movement of electrons. You know that very well, na? That whenever electrons are moving, they can easily show the different properties, like it could be electrical property or it could be the magnetic property. Okay, so each electron, whenever it is revolving around the nucleus of the atom, it is behaving like an magnet. Suppose this is our nucleus and electrons are revolving. So I'm saying that each electron behaves like a tiny magnet, like a small magnet. And the reason behind this is the movement. Basically, we can understand the movement of electrons just like the earth is revolving. The earth has two different directions. The first direction is that it can revolve around the sun, and the second one, it is also its own axis. In the very same way, I can say that electron is revolving around the nucleus, and secondly, it is also rotating on its own axis. It's also rotating on its own axis. Okay, so on the basis of these two movements, there are some magnetic properties, there are some magnetic, we can say, nature of electrons which are associated with. Okay, so let me recapitulate what I want to describe to you. I want to say that due to movement of electrons, as they are revolving every time around the nucleus, they can behave like a small magnet, like a teeny magnet. Okay, and these movements are basically of two types. First one, that our electron is revolving around the nucleus, and the second one is our electron is rotating around its own axis. Okay, so this is the case that how our electrons can behave like magnetic properties. They can behave like a magnet. Okay, so now let's start with different type of magnetic properties. Okay, but the point is that whenever I have told you that each electron, they're revolving, they have a permanent spin, the reason is that whenever they have their magnetic properties, their magnetic moment is quite low. Okay, and we represent them in the form of Bohr magneton, or we can say it Bm. Okay, and what I am saying? I'm saying that electron has a permanent spin. So permanent spin would create a permanent magnetic moment. But this topic you have studied in your 11th class, that our electron are spinning with two types, like +1/2 and -1/2. That our electrons, they are having +1/2 and -1/2, the spinning. Okay, in 11th class we have studied the spin magnetic moment. In the very same case, I'm trying to describe you that whenever it is moving, they have a spin due to which a magnetic moment is created. But the point is the magnetic moment is very small, the value of it is very low, and we represent it in the form of Bohr magnetism. Bm is its unit. Okay, Ji? This was the old topic of magnetic properties of electron. Now the point is on the basis of these magnetic properties of our electrons, we can let's start. How can we differentiate them and what are they actually want to convey to us? So let's start. Basically, on the basis of magnetic properties, there are total 5 types of compounds, or we can say our solids. है ना? So those 5 types of solids are paramagnetic, dimagnetic, and ferromagnetic. Then is and last one is Fairymagnetism. So paramagnetic, diamagnetic, ferromagnetic, antiferromagnetic, and last one is Fairymagnetism, which is totally different from all these topics. Okay. So now we will start what are the paramagnetic and the diamagnetic. I hope you have heard about the topic paramagnetic and diamagnetic in your lower classes in 10th or 11th somewhere. Basically, the paramagnetic and the diamagnetic both are due to the magnetic nature, but the reason is paramagnetic substances are those which are weakly attracted by magnetic field. What I am saying that paramagnetic substances are those that are weakly attracted by magnetic field. And another point is that they can be aligned in the same direction. What does it mean? It means that whenever we are applying a magnetic field and we are putting our paramagnetism, then the nature, or we can say the direction of magnetic field and the direction of paramagnetic field is exactly same. They are weakly attracted by the magnetic field, that whenever I have put a magnetic field over there, these paramagnetic substances start attracting to that particular magnetic field. And we have studied in our 9th class that magnetic field is totally dependent upon the directions. We have described this, that our magnetic field, our electric field, they're totally direction dependent. So it also wants to say to us that they can be aligned to the same direction in which magnetic field is applied. In which magnetic field is applied. Okay. And lastly, the most important point, para means unpaired. Para means unpaired. You have heard this line. I'm damn sure you have heard this particular case, that paramagnetic substances are those which have unpaired electrons. Due to these unpaired electrons, they show magnetic property known as paramagnetism. Okay, so the substances show all these properties, they are known to be paramagnetic substance, and their property is known as paramagnetism. Now, I want to give you some examples that are copper 2 positive, O2, chromium 3 positive, and many more. These are some metallic compounds which show paramagnetic in their nature. Okay, now let's move with our next topic, that is diamagnetism. Diamagnetism is quite different to it, this particular topic? And how can we understand it? In paramagnetic, we have told that by magnetic field. But if I'm talking about the diamagnetic, I am saying they are weakly repelled by magnetic field. The first difference between the paramagnetism and diamagnetism is that these are weakly attracted but weakly repelled. And I have told you that they are attracted in the same direction in which magnetic field is applied, but they are aligned, or I can say they are repelled in the opposite direction, in the opposite direction in which magnetic field is applied. Okay, the next point is, I have told you that if there is unpaired electrons, only then there is the characteristic of magnetic nature, that is paramagnetic. But if I'm talking about the diamagnetic substances are those which have completely paired electrons, which have completely paired electrons. That's why diamagnetic are those which would show small magnetic field. You know what I'm talking, that if these are paired, the magnetic field, the magnetic nature would be cancelled out. Okay, and they would show very small magnetic field. Now, examples of these are, suppose benzene, C6H6. Let me give you one or more example also. These are water and sodium chloride. Okay, so this is about the paramagnetism and the diamagnetism. The paramagnetism is something which is weakly attracted, diamagnetism is something which is weakly repelled. And the most importantly, this is due to unpaired electrons, whereas diamagnetism is due to completely paired electrons. I'm sure that you don't have any doubt about the unpaired and the paired electrons. Think you know that about it very well. Okay, so this is the difference between paramagnetism and diamagnetism. Now we are left with our three more topics: ferro, antiferro, and ferromagnetism. So let's start what ferromagnetism wants to convey to us. Let's start. I'm just gonna rub this particular topic and we will start with ferromagnetism. Now, what ferromagnetism is? Okay, in ferromagnetism, there are some compounds like chromium oxide, like cuprous oxide, and many more. These are some compounds which are strongly attracted by the magnetic field. These are something which are strongly attracted by the magnetic field. Okay, so due to this strongly magnetic field, whenever they're attracted, they show the permanent magnetism. The permanent. Now, you should have a query that what does mean by permanent magnetism? The permanent magnetism means whatever I was talking about the diamagnetic and paramagnetic, what's happening, whenever I am just removing the magnetic field, they would start losing their magnetic nature. Okay, they won't show any kind of magnetic nature or any kind of permanent magnetism. But ferromagnetic are those substances, whenever I have put them in magnetic field, and after 5 minutes, after 10 minutes, in which they have acquired the magnetic character, and I am removing the magnetic field, still in the absence of magnetic field, they would show the permanent magnetism. They would still show the magnetic character. And this is known as the best property of ferromagnetism. Clear? Now, the next concept is how can we further elaborate about the ferromagnetism? See, the solids have some molecules which are in the form of small magnets known as domain. What I am saying that ferromagnetism, or if I'm talking about the solids have some molecular compounds, or we can see some molecular orbitals which are behaving like a magnet known as domain. Okay, so each domain is behaving like a magnet, and whenever they are grouped together, we want to see that how they are oriented. So I am talking that the domains are something in which our molecules are arranged in small groups, okay, and each domain is behaving like a magnetic field. And I am saying that each domain are perfectly aligned in the same direction. These are perfectly aligned in the same direction. This is a kind of electron, you know, where so if the domains are perfectly aligned in the same direction, in the same orientation, this is known as ferromagnetism. Okay. Why I'm stressing on this particular topic that they are aligned in the same direction, they're aligned in the same direction, because whenever we would go to antiferro and the ferry, they are just opposite to them. Okay. So let's start with our next topic. What is antiferromagnetism? Okay, the antiferromagnetism are something which is completely different, and I would say these are the example of manganese oxide. We have been provided with only a single example, that some substances which have domain structure similar to ferromagnetism, but the point is their orientation is totally different. Their orientation is totally different. That means they are in anti-parallel fashion. They are arranged in anti-parallel direction. Like one is in the upper direction, in the +1/2 direction, other opposite magnetic moment, and they would give the whole magnetic moment, which is known as antiferromagnetism. So ferromagnetism and antiferromagnetism, they are totally different to each other. They are totally opposite to each other. And the main difference, the main reason behind this is that these are aligned in the same direction, whereas these are aligned in the opposite direction. Okay. Now let's move with our last topic. What is ferrymagnetism? What is ferrymagnetism? Okay. Now, what I have told you that our ferro and antiferro, these are strongly attracted by the magnetic field. If I'm talking about the ferrymagnetism, let me rub this. If I'm talking about the ferrymagnetism, they are strongly, oh, sorry, not strongly, I should say they are weakly attracted by the magnetic field. But the main difference, we can say concept to differentiate our ferro and antiferro is that their domains are arranged in parallel, anti-parallel manner, which do not have any fixed order. So this is something like they have both the parallel and anti-parallel direction, the +1/2 and the -1/2, but they do not have any kind of fixed order. They do not have any kind of fixed range, we can say. So suppose first one is in the parallel direction, in the +1/2, other one is in the -1/2. Then these three are in the same direction, they are parallel to each other. Then there is anti-parallel. So there is not any kind of fixed or permanent region which is known as ferromagnetic substance. And the best point about this is whenever we heat them, their magnetic character is gone away. Their magnetic character is lost away and they are behaving like a paramagnetic substance. So on heating, they behave like a paramagnetic substance. So class, have you got the difference? The ferro and antiferro were permanent magnets. The ferromagnetic substances were something which were permanent magnet even when we remove the magnetic field from them. But in ferromagnetism, what is the point? Due to their anti-parallel or due to their not fixed fashion or order, what's happening? Their magnetic nature is losing away after just heating them. And they're behaving like a paramagnetic substance. Okay, so this is something which is known as ferromagnetism. Now I would give you some, for example, Fe2O3 or Fe3O4, that is ferrite and ferrous ions. These are known as our ferromagnetic compounds. Okay, so this was all the concept, which was a theoretical topic, quite obviously, but I have tried to deliver you with the help of diagrams, with the help of domains. Okay, so these were the 5 different types of compounds on the basis of which we have observed the magnetic nature of our. Okay, now we have some time left, so I would start 2-3 more numericals, 2-3 more questions of our back exercise, and then we will have our chapter 1 is completely finished, but let me show you some questions. Okay, in your NCERT book. Let's start with the back exercise. The question number 1 is, what is amorphous solid and how can we exemplify them? This is why it's a very simple question. In the first class, we have studied the amorphous solid. Amorphous is something which is defined as which do not have the perfect order or perfect range in which our compounds are aligned. And the example are plastic and glass. Now the question is, second question, what makes a glass different from a solid such as quartz? Under which condition could quartz be converted into glass? Yes, this is the difference between crystalline and amorphous. Amorphous is our glass and the solid is crystalline. So the question is, can a quartz be converted into glass? Yes, definitely. The silicon oxide, that is the quartz, can be converted into glass by changing some physical properties, like we can heat them, we can boil them, and we can change their perfect order into short range order. Okay, same as it is, we have the question tetraphosphorus dicoxide, that is P4O10, graphite, brass, and we have to define them on the basis of molecular or ionic solid or amorphous solid. But this was the topic which we have discovered in our first class, so I hope you can easily deal with this, but I'll give some example. For example, I2, this is our molecular compound. For example, sodium chloride, this is our ionic. And for example, glass, this is our amorphous solid. Okay. Now the next question is, what is meant by term coordination number? What is coordination number? I have told you this in our compound, in which we have studied how can we make 1 order to 2 order to 3 order, and the close packing. So coordination number is something which have told us that how many number of neighboring atoms or molecules are fixed with a particular atom, And we have seen that in our hexagonal close packing, it is equal to 12. In our cubic close packing, it is equal to 6. So all these terms we have discussed in the coordination number. Something which is very important. The question is, we have given the density and the mass. Can we relate them? Yes, definitely we relate them with the formula, this one. I have told you, class, this is the super important topic. This is the super important formula, because on the basis of this, you will definitely get a numerical in your board exam. Not only in the board exam, even if you're focusing on your NEET exam or your IIT or something, you will get the question on this competitive topic, because this is very important formula. How is it related? The rho is representing density over here. The Z is something, the number of atoms each cell represent. The unit cell, like I'm talking about the simple unit cell, it would have 1. If I'm talking about the face center, it would have the 4, and the body center have 2 number of atoms. Okay. M is the mass, and note is the Avogadro number, and A is the edge length. Okay, so this was whole about the topic of the solid state. We have finished our chapter, the solid state. And if you have any kind of doubt or queries, then please let me know. We will discuss them. Yes, students, please ask me any kind of doubt or query.